Hey everybody, welcome to this week's first video. So we're going to talk about functions again. This whole term will basically be about functions, but as we will see today, there will be some complexity to it. So yeah, basically, before I go on, I'd like to review. What's a function, guys? Well, as you answered in your quiz, and we have a quiz this week, by the way, but it said this is a mathematical relation such that each input only has one output. So what if we use the definitions that we learned, domain and ranges, like a domain and range. So because we can redefine our function as, let's see, your definition, a function is a relation. All right, let's stay there. But you could say that a relation that matches each input in the domain to an output in the range. All right, we have a new and improved function definition. So again, if you go to our mapping diagram, if you remember these guys, let's say we have something like this, 4, and then we have 6, 7, 8, 9. If it maps out like that, nothing is crossing per se. So long as nothing is crossing per se, no inputs are similar. As long as no inputs are repeating, all right? No inputs are repeating. We have a function. Awesome. So, what about this guy? You think this is a function? No. Inputs are repeating. What about this guy? Oh, I'd say so. Yeah, it's good. Yeah, it's good. How about this guy? Yes. Outputs. Yo, hold on. Yes. Outputs are repeating, but that's okay. All right? It's okay for outputs to repeat. All right? Outputs can repeat, but inputs don't repeat. All right? So this is some things I want you to think about going into this next section. All right? So yeah, basically, yeah. So let's start our new section here. All right? We have two types of functions. All right? We have two types of functions. We have one-to-one functions and onto, and the functions that are referred to as onto. So what's a one-to-one function? All right? So yeah, like we have functions. Then we've got one-to-one or onto, then one-to-one. All right? And these one-to-one or onto functions can either be discrete or continuous. All right? Don't confuse that. All right? Remember, relations, just a little recap. Relations can be, we have two types, discrete or continuous. All right? And then a type of relation is a function. All right, a function. So because a function is a relation, it can be discrete or continuous. All right? So, but those aren't types of functions. Think about discreteness and continuity as a characteristic of a relation, and one-to-one and onto functions as types, the no characteristics are types. All right, types of our functions. So anyway, back to the video. So that's just all right. So what's a one-to-one function? Oops. So a function such that, let's just st, such that every input in the domain has a unique output in the range. And this is the big part. And vice versa. All right, and vice versa. All right. So you remember in this example here, we have a repeating output. So this wouldn't be a one-to-one function because it's a function, but it will not be one-to-one. All right, because the outputs are repeating. Anyway, so example of a one-to-one function. If I have and also we had these as inputs and outputs. Today we're gonna call them domain and ranges. So this is another, some more notations. All right, domain, range, domain, range. All right. I remember we had inputs, outputs, so we're graduating to domain and range. But anyway, so back to here. So for our one-to-one functions, we got our domain and our range. All right. So our domain and range, basically, we have, let's see, example of one-to-one function, 1, 2, 3, and then 4, 5, 6. So, this maps. Nice. So you see, each element in my set of domains is unique and produces a unique range. All right, and each range, each range produces a unique element in the domain. All right. So anyway, so something that would not be one-to-one, it would be if any of the elements are repeating in each set. Like I got 666 over there. Don't worry, I'm not the devil or anything. It's a coincidence. Or even if the inputs are repeating, it's just not a function. So to test whether a function is one-to-one, check if the outputs are repeating. You see, this wouldn't be a one-to-one function. So not one-to-one. Although it's still a function. All right, it's still a function. Nice. Now onto no pun intended. An onto function, this is the confusing one, all right? This is the very, very confusing one. But I just want you to trust me on the definition, okay? I'm going to change the color because I don't want too much red just going around. So, yeah. Anyway, so onto, so I'll say an onto function, all right, is a function. So there's a function that has its range including every output value that belongs to the set of outputs we are considering. Sorry guys, not enough space. All right, so an example of a function that's onto actually would be, let's see, we have, so well, basically we want to make sure that on our domain and our range, we have corresponding, like every value in this every value here is used. All right. So now here I have a word. I have something that's I say. I phrase here. It says outputs we are considering. All right. So the set of outputs we're considering has a name. All right, and that name is the codomain. All right. The set of outputs we're considering is referred to the codomain, like codomain. All right. I don't want you to get confused. Okay. I know, but just try to keep track. So actually, you know, what we're calling the range in this mapping notation, just trust me here, is actually the codomain. The codomain equals the range. When the codomain equals the range, we can use them interchangeably. Like here, my codomain, I can say I wanted this set of numbers 5, 6, 7, 8, 9. I wanted to use these numbers, the numbers I'm interested in. So there will be the codomain. But when the codomain, when the numbers we're interested in, like for example, if I have, let me just redo this part, or I think I get a smaller eraser. If I have a particular amount of numbers, like if it's a 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3. This maps out like this. And I leave out 7. All right, I leave out 7. That makes 7. So that makes the set of, so here the set of my codomain is 4, 5, 6, 7. But my range here is 4, 5, 6. So what does that mean? This basically means this function here is not onto, all right? So not onto, all right? It's not onto because my codomain does not equal my range, all right? So the question to ask yourself when finding out whether a function is onto is, does the codomain equal the range? Yes, no. All right. So yeah, not. So now this one, I guess I should have an example of a function that's onto. So I'm just gonna say onto. So my onto function. Sorry, let me put some nice parentheses here for you guys. I know I've been fussy with the parentheses lately. So yeah. So an onto function is just any function that the codomain equals the range. All right. Here there's no 7. On this side, my codomain is 4, 5, 6, and my range is 4, 5, 6. All right. So that's the gist of an onto function. Codomain equals range. All right. So here, instead of saying outputs we are considering, oopsie. What? Sorry, guys. Sometimes this. So instead of saying the set of outputs we're considering, so every output value that belongs to the set. Sorry, every output value that belongs to our codomain. All right, awesome. So let's do some examples. Is this one-to-one or is this one-to-one? So we have a simple test to see if a function is one-to-one. All right. A function. So yeah, for it to be one-to-one, remember it has to have a unique set of values in its domain and a unique set of values in its range. So if outputs are repeating, for example, then we can use the HLT, the horizontal line test. Horizontal line test. Every time to test if a function is one-to-one, use the horizontal line test. So if I put a horizontal line here, oh look, I have an input here, and sorry, that's an output. But see, I have two different inputs sharing the same output. All right, two different inputs are sharing the same output. All right, that's a function, quite right, but it fails the horizontal line test. So this is not one-to-one. You are not one-to-one. So no. And then what about this one? If you use the horizontal line test. Yes. You are one-to-one. Okay? Yes, that's one-to-one. Now what about onto? Onto, a function is onto, so what we said, every set of numbers in the codomain is equal to the numbers in the range, all right? Well, here, I can safely say that this guy here is onto, all right? And that's because every number, like this is a line, lines go to infinity. So it's including, unless I add an endpoint or unless I say it's not going to infinity, I can just tell you that it's going to include every possible value in your range and every possible value in your domain. All right? So that's onto. Now this guy over here is interesting. It's not onto because we are missing a few y values here. We're only considering y greater than 0, greater or equal to 0, but we're not including y values. And still, even that one I told you is a bit hand wavy, but for today it will do. And I hope to get our worksheet. I hope to have our worksheet tomorrow, able to allow us to be able to finalize all of this. All right. Anyway, I hope you have a good night, and I hope you have I hope you had a restful weekend. See you tomorrow in class. Bye.